Okay, so there's 4 different ways that we have listed here that we can combine 2 given functions into another function. And they are the same 4 operations that we learned how to deal with when we learned how to do arithmetic, which are add, subtract, multiply, and divide. So if we want to find the sum of 2 functions, okay, we ultimately just need to add them together, subtract to get the difference, multiply to get the quotient, or the product I should say, and then divide to get the quotient. And one stipulation, of course, when we have a quotient is that the g function can't equal 0. Otherwise, okay, we'd have issues with our domain. Okay. All right. Besides being able to put functions together, which we're going to look at in just a minute, okay, note here it says in each case the domain of the new function consists of all the numbers that belong to both the domain of f and the domain of g. Okay. So ultimately, we're going to be asked to put functions together in the following manners. Okay, and then we're going to be asked for what is the domain of the result. Okay, so that's what our work is going to look like. So let's take a look at an example here. For the first one, it says we have f of x equals x cubed, and g of x is equal to the square root of x plus 1. And we're going to find formulas for each of these different types, okay, which are the 2 added together, subtracted, multiplied, and divided. So let's start with the added. If we're going to add these 2 together, if we go x cubed plus x plus 1 to get our new function, okay, the only other thing that we could possibly do here when we add 2 functions together is, are there any like terms that we could combine? And in this particular case, there's nothing more we can do. We just put a plus sign between them and we're done. Okay. Now, the other part that we're going to do here is talk about the domain. Okay. So when we look at the new function that we have here, okay, we need to start with each individual part, and you might want to do that before you start. Okay, before you start putting them together, is determine what the domains are individually. X cubed we know its domain is negative infinity to infinity. Okay. And then this g of x function, we know that we can't have negatives under the radical. Okay, so numbers that would make this negative would be anything like negative 2, negative 3, negative 4, and so on. So, and we know that would start at negative 1. So negative 1 to infinity would be our domain for that one. Keeping in mind that negative 1 is okay because it's okay to have the square root of 0. Okay. So this would be our domain. Again, anything to the right of negative 1 is going to make this positive, which is good. That's what we want. Okay. And then from here, the question is, what's the domain of this then? So what would be the domain of the addition of the 2? Well, again, even though this one is negative infinity to infinity, this now being a new function, okay, what can't we put in it? We can't put negative 2, negative 3, and so on. So ultimately, which domain are we going to take for this new function? We're going to take this one, aren't we? Okay. So even though in the x cubed part we can put negatives into it, okay, less than negative 1, okay, we can't put anything less than negative 1 in here, so the domain of our new function, okay, becomes ultimately the domain of this one. Okay. Question so far? What if we were to subtract those 2? Again, adding and subtracting are like term situations. There are no like terms here, so we just have to leave it like that. Okay. And how about domain? Any different than what we just had for the first one? So we'd have negative 1 to infinity. Again. Okay. If we were to multiply these 2, if we were to go x cubed times x plus 1, okay, and get a new function, okay, we need to again ask about the domain. Okay. Still, I can put anything I want to in here, but what can I put in this part? Still can't put numbers less than negative 1 here, so domain remains the same. Okay. Okay. And then finally, if I do f divided by g, and I have x cubed on top, x cubed plus 1 on, or x cubed plus 1, just x plus 1, I should say. So x plus 1 on the bottom. Okay. One thing that when we're dealing with putting functions together like this, we might ask, is it okay to have the radical on the bottom? Okay. And the answer in this case is yes. It is okay to have the radical on the bottom when we're building functions like this. So if you leave it like that, that's fine. The domain issue here at this point, though, is we still have that same function that we can't put anything less than negative 1 into, but there's one difference this time. If I were to put -1 in this time, normally that would be okay, but since this is on the bottom, it's going to make a what? It's going to make a 0 on the bottom now if I put a -1 in, so now I can't include -1 on that particular part. Okay. All right, now, again, with our calculator, we can double check our work here and see if what we think is actually correct. So if we put in the functions, we have x cubed, and show the lights one more time, Isabel. If I do square root of x plus 1, and draw my graph, okay, you'll notice that the starting point here was at -1, as we suspected. One thing to check also, to double check, make sure that's right, is use your table as well. Okay, if you do your table on here, I'm going to clear out my table just so I can type what I want to in here. If I put -1 in there, I'm going to get -1. So -1 is good for the domain. It gives me a legitimate answer here, of course. But if I put -2 in there, it gives me an error. In fact, if I put -1.0001, okay, something really close to -1, but on the left side of it, okay, I get what? I get an error. Okay. All right. And if I do that same thing, if I look at the graphs of the subtraction combination, if you will, okay, should see similar in terms of the domain part, okay, which we do. If I were to look at the multiplication of the two, once again, the domain appears to start at -1 again, like we suspected. And then if we do the division of the two, and it looks like -1 here is where we start, but if you look at your table again, notice -1 itself gives an error, like it should. Okay. But anything just on the other side of -1 should be good, like if I did -0.9999, okay, we do get a value for it. Okay. All right. Matter of fact, if I were to go -0.999999, many nines, okay, notice it's a super huge number right here. Okay, what does that indicate? That for this particular function, that -1 is actually a what? It's an asymptote, isn't it? And one thing to recognize with that, and that's why I use not only graph but also table, because if I told you to just look at the graph, okay, would you tell for sure that that's an asymptote by looking at that? You might not think so, would you? Okay. Now we know that generally if there's something that makes the bottom 0 here, that we're probably going to have an asymptote. Okay. So knowing that from the algebra part shouldn't be too surprising, but if you just look at the graph only, okay, your calculator doesn't actually draw the asymptote usually, so kind of difficult to tell by looking at the picture. But if you use the table, then it's pretty obvious, isn't it? Okay. All right, questions so far? All right. Now, there's a fifth operation that we do with functions, and that's called what we, composition. Okay. All right. So the definition of composition is here. So we have two functions, f and g. So the domain of f, okay, intersects the range of g. Okay, that part is less important than what we're going to do with it with the notation here. But when we say the composition f of g, this is how we say it in English when we read it. Okay, it's denoted by f with a circle, an open circle between the f and the g. Okay, that is read f of g. Okay, and again, when we have it in terms of an x variable, we write it as f of g of x, and that's also equal to this notation too. All of these notations are equal to each other. Okay, so any way it's given to us, okay, it means the composition, okay, f and g. Now, I'll talk about the domain in a minute, but what it boils down to when we do f of g, okay, all we're doing is we're plugging the g of x function into the f of x function. Okay, so we're plugging the g of x function into the f of x function when we are doing the composition. Okay. And finally, for to look at an example, the domain of the composition consists of all the x values in the domain of G that map the G values in the domain of F. Now, that sounds rather confusing, I agree, okay? But we're going to see it in action because it's not really as difficult as it sounds. Okay? All right, so if we take a look at an example, okay. This time we have 2 to the x, and we have that same g of x function, which is radical x plus 1. Okay, knowing that we're going to be dealing with domains here, I'm going to write the domains down. We know that the 2 to the x function is an exponential function. Okay, it looks like e to the x, okay, very much like e to the x. Okay, the base is a little bit different, but it's still an exponential growth function. And then we said that this one is -1 to infinity, so keep those in mind. Okay. All right, now in part A, okay, we're asked here to do f of g of x. So knowing that, and I like to write it like this because that kind of illustrates what I wrote in words a minute ago. Okay, that we're going to take the g function, okay, and we're going to plug it into the f function. Okay, because remember earlier, if I told you to do f of 5, we learned, okay, that means that I'm going to put a 5 into the f function. True? But instead of putting a number in, okay, what am I going to put in instead? I'm going to put in a function. I'm going to put in an expression that has letters in it. Fair enough? But it's the same concept. I'm going to take, just like over here when I take 5 and put it into the function, okay, now I'm going to take an actual expression and put it into the function instead. So therefore that's going to look like this. Okay, remember the f function is 2 to the something. Okay, any x that we have in f is going to get replaced by g. So ultimately it's going to be 2 to the x plus 1. Okay. All right, so just like over here, I replaced the x with 5. Okay, over here, I'm going to replace the x with radical x plus 1. Like I said, instead of plugging in a number, I'm plugging in an actual function. Okay, so this is our new function. Okay, and let's talk about its domain. Okay, we know that we can put anything into 2 to the whatever if we want to, but still bottom line is though, what can't go in here? You know, we can't put any -1 or -1 less than -1s. So the domain here would still be that. Okay. Okay. All right. Now, in part B here, notice that we have it written backwards. It's g of f this time. So in the other notation, I would write that as g of f of x, which means that now we're going to take the f function and plug it into the g function. So remember the g function is this, so it's going to be the square root of, okay, and then in replacing x here, we're going to replace it with f. So it's going to be 2 to the x plus 1. All right. Again, no different than if I were to do g of 5. If I did g of 5, I would be plugging a 5 in for x. True? Okay. If I want g of 5, I'm putting a 5 in for any x's I see over here on the right. Okay, so when I want g of f of x, what am I replacing all x's with? I'm replacing it with the function f. Okay, and this is now my new equation. Okay. Now, that said, what about the domain here? Okay. Well, remember, this can't be less than 0, true? But if this is an exponential growth function, which is never less than 0, and we add 1 to it, can this argument part be less than 0 ever? Okay. So if we're just looking at this function only, okay, couldn't we say negative infinity to infinity? Okay, if this was the initial given function. Okay. All right. Now, there's one issue though that we got to talk about though, and that's that if we actually build a function from 2 other functions, okay, we need to consider all the domains possible here. Okay, so even though if this was given to us and it didn't come from something that we made, okay, we could say that the domain here would be negative infinity to infinity. Okay, if either of our initial functions have restrictions, okay, then those same restrictions have to be on our created function. Okay, so like I said, even though, okay, if we didn't know what this was made from, okay, if we didn't create this ourselves, Okay, if we were just given this, we know that there's no way that can be less than 0, so we could put anything we want to in there. But because it came from this function originally, which had a domain restriction, okay, our answer needs to have a domain restriction also. Okay, so even though normally we could put anything we want to in here, okay, we still can only use the numbers that are -1 to infinity here. Okay. All right. Questions so far? Okay, just to re-illustrate one more time, let's go back to our f and g that we had over here a minute ago. Okay. If I want to have f of g of x, let's see what that would look like in another example here. Okay. So if I want to write down what's f of g of x, that means I'm taking the g function, plugging it into the f function. So instead of cubing x, I'm going to cube x plus 1, square root. Okay. So again, that would be what it would look like if I were to put the g function into the f function. Okay. All right. And one thing to consider here too is that could something like that be possibly simplified? You know, what that means is that it means this thing multiplied by itself 3 times, wouldn't it? And think about if I multiplied it by itself 2 times, the radical would go away, wouldn't it? And then multiply by another radical. So I could rewrite this as x plus 1 times radical x plus 1. Would be another way to write it. Simplified form. Still, same domain issue here. Okay, what about g of f? What would g of f look like? If I did g of f, that means I'm putting the f function into the g function. And that means that I'm going to take this, plug it in here, and so this time I'd have the cube root of x, or square root of x cubed plus 1. Because again, I'm putting the x cubed function in for the x in the other function. And then again, domain-wise, okay, we'd need to know when does x cubed plus 1, okay, when is that essentially negative, okay? So we could figure out that. Keep in mind it's a cubic, so we'd use a calculator to find out when this becomes negative, okay? And that would be part of our domain restriction this time.